Hello students, welcome back. In this video, we're going to start our puzzle sorting game, Broshi. We'll focus on two main things here, our gameplay world and our player. So we'll build out the world, and then we'll create our player object who will interact with all of the objects within that world. So let's head to the computer screen and we'll dive right into our first lesson. So I have a web browser open here, and I am going to go to vscode.dev because I'm going to use a web-based IDE to write all my code. No software installation needed here. Of course, if you have your own code editor installed on your computer that you like, feel free to use it, but I'm going to do everything right here in the web. So in vscode.dev, I'll select Open Folder, and I'm going to go to my desktop, which is where I have saved my Broshi folder that we downloaded, and I will select Folder. I will allow, and I will trust the authors of the files in this folder because those authors are myself, so I can trust me. And now when we do that, we see that we open up 8 folders over here. Each one of these folders is a lesson that we will work together to create our game. Now, if we open them up, each folder contains 2 files, a starter file and a final file. The starter file is where we will always begin. We are going to work here in this starter file, making changes to this. But I gave you for each lesson a final version of the code for that lesson. That way, if you ever need to go reference what the working code looks like, you have it right here. Now, I'm going to open up my starter file because this is where we will be working for lesson number 1, but I'm also going to minimize my web browser right now. And I'm going to head to my Broshi folder and go to lesson number 1 and open the starter file directly in the web browser because this is going to allow me to look at the current state of our game. And so here is the current state of Broshi. Okay, very weird looking. We got these like little white eyeballs right down here on an odd color scheme, no keyboard movement. I'm not able to move anything or interact with this game at all. So this gets the stamp of broken game. All right, this gets my broken game stamp. So we got to fix this. And so the way we're going to fix this is by heading to vscode.dev and editing our lesson 1 starter file. But before we get to that, I want to just sort of overview what is in this file. So to begin, this is an HTML file, hypertext markup language. That's essentially the language of the internet. All of the content that you see on the internet comes in the form of an HTML file. And HTML is built up of these things called tags. Now, a tag is something that just sits inside of an angled brackets. So here is the title tag. There is an opening to the title tag and a closing to the title tag. So most HTML tags, you open them and you close them. You open them and you close them. And then you put content inside of the tag. And so right now, our content inside the title tag is Broshi. And you can see that right here in the tab, we have a title for our website, Broshi. So if I change that, I'm going to change that to put my first name in, and it will ask me to save those specific changes. If I come over here and refresh my tab now, those changes take place. So we can edit our file, save it, and then see those changes in real time. Now, I don't like the name Mike for the title of my game. I'm going to go back to Broshi, and I'll do it with a Control-Z to undo those changes. So let's look at the next tag that we have. We have what's called a script tag. Here is our opening tag, which seems extremely long. And here is our closing tag. And if you notice, in between the opening and closing tag, there is nothing. Nothing is here. So you might say, well, what is the point of this particular tag if there is no content inside of the tag? Well, a script tag is where we place JavaScript, which is our programming language for the internet that we are going to use. We're going to make our web-based games here using JavaScript. Now, we have no code inside of this first script tag. There's no code here. So we have to focus on the opening tag. This opening tag has this really long source for a URL where we can bring in or import our own external library of JavaScript. And that's exactly what we're doing here. We are bringing in a library known as the P5 JavaScript library. So the P5 library is going to be super, super helpful for us in making our games. It's going to give us access to a bunch of functions that we can use here in our program that will help us render graphics to the screen. Rendering things or drawing things like these columns, these vertical lines, this text text right here. What I'm assuming is our player. We can draw shapes. We can draw colors. We can do it with ease using the P5 library. So we're going to leverage this library a lot here in our videos. Now let's just see what else we got. We got like a style tag and all right, a body tag. Ooh, look, another script tag. So here's where we open a second script tag. And if we look, there is a lot of JavaScript in here. In fact, if I scroll all the way down to here we go, line 286. There's our closing script tag. So everything in between that opening script tag and this closing script tag represents the JavaScript code for our game. It is the current state of our game. Now, let's go see what's inside of here. So I'm going to scroll all the way back up here. To begin at the top here, it looks like we have our game name and lesson, the world and player, and then we see something called a mission checklist. The mission checklist is a collection of 8 small missions that we are going to solve together. And in solving these 8 missions here, we're going to take our terrible state of our game. And if you forgot, this right here is that terrible, terrible, terrible state. And we are going to make it better. We're going to make it look better, play better, and feel better by solving these 8 missions. Now, if we go just a little bit lower, we enter something called the student edit zone, where it says these are values that are safe to modify. These are essentially like knobs or dials that you can turn up or turn down to change how the game plays, looks, or feels. Any change that you make here should not break your game. For example, look, we have a mission right here where it's asked to increase the player size. So we can change the value of this variable right here, and it will directly impact how big our player is. We also have colors that we can change, so we can change what our color scheme is. But then we end the student edit zone. So all the changes that you make up here will not break your game. You might say, okay, I want my player to be a different color. Come on in and make that change. But outside of the student edit zone, you have to be careful. Any changes that you make, if they are not correct, could potentially break your game. So if you change this line right here, line 105, and it breaks your game and you don't know what to do, you can always go back to the final version of the completed game, the correct code, and go to line 105 and see what that line should have looked like. So again, you have the final version as a safety net, as a fallback. Now, let's look at what we have outside of the student edit zone. We have some gameplay variables that we'll most certainly talk about, and then we see some functions. Functions are going to be extremely important for us because we are going to use functional programming to write our JavaScript games. A function is just like a set of instructions. So if you look at right here, my setup function, that's the name of this function, has 3 instructions in it. So anytime I want to run those instructions, I just call the setup function. So calling the setup function is going to create my canvas, which has a canvas width of 640 pixels and a height of 700 pixels. It's going to set my text font and that to monospace, and then it's going to call another function, reset game to defaults. It's going to, basically put my game back in the beginning of the beginning state of the game. And so anytime I want to do these 3 lines, all I have to do is call my setup function. Now, the setup function is super important because it's part of the P5 library, that P5 JavaScript library that we imported into our program in our first script tag. And it will get called or run automatically every time you start your game. So I hit refresh. That function just got called. I hit refresh, that setup function just got called again. Now, the draw function is another P5 game loop function that will get called not at the start of our game, but instead it will get called every single frame of our game. So if our game is running at 60 frames per second, this function is going to get called 60 times in a second. And what is it doing? Well, the instructions say update our player and draw our scene. So these are 2 other functions. So this function is going to call 2 other functions every single frame of our game. So now let's go look at what some of our own personal functions are. So these are functions that we have to call. Here is reset game to defaults. Remember, we called that function right here in our setup function. So it looks like here we're just like resetting everything for our game. I have update player. We're calling that inside of our draw function to update our player. What else do we got? We've got get input direction. Okay, so we got to figure out what that does. And then draw scene. We're calling draw scene inside of our draw function, which gets run every frame of our game. And here we're calling draw background, draw drop zone, draw player, draw HUD. So it looks like we have a bunch of drawing functions that we're going to work through. So really, to me, it feels like there's three things going on. And so I'm going to jump all the way back up to my student edit zone. And the way I can do that is over here on the right, I can just click in this sort of window. And I'm going to go, this green area is my mission checklist. And if I look right down here, I have my student edit zone. So a nice little way to jump. It seems like we're doing three things. We are defining data. And so here's where we're defining data. We're creating a bunch of variables and setting their values. So we define our data. Then it looks like we're updating our data. So we update our data to reset our game defaults. We have update player. We get our input directions. So we're updating directions based off of keyboard presses. And then we are drawing our data. We have all of these draw functions. So we are going to approach our game development here in three layers. We must define data, update data, and then draw our data. And we're going to keep coming back to that structure: define, update, and draw. So with all of that said, now that we have an overview of what's in one of our HTML files, let's go back to the mission checklist and let's begin looking at mission number one. Mission number one in the mission checklist says, change the background color to create a new world atmosphere. Because right now, I don't know, our atmosphere is pretty bad. I kind of don't like it. So we're going to try to fix that. So now where do I go from here to find mission number one? I mean, I could just start scrolling through my code in hopes to find it, but I'm going to show you a little trick. Mission one, those words right there, mission space one, is a tag. And that tag only appears twice in this entire program. It appears once in the mission checklist, and then it appears somewhere else where the code is that we have to edit. So the way we're going to do this is we are going to hit Control F on our keyboard or Command F on our keyboard, and it's going to open up our search bar. Now, if you have a phrase highlighted, that phrase will populate right in here, but if it's not in there, just type mission one, all capital letters, mission one. Now, you can see here we have one of two instances of mission one. We're right here in the mission checklist, and if I hit up or down, I'll go to the previous or next match. So I'll hit down, and it brings me right to mission one, world atmosphere. We have to change the background color and observe how the mood of the world changes. Now, let's think about this for a second. I always like to know where I'm working within my code structure when I'm doing a mission. We are changing background color. That doesn't seem like something that should break our game if we mess it up. So if I scroll up, we find that we are in that student edit zone, that space where we can safely change values and not break our game. So let's look. Looks like we got two colors here under the world atmosphere. We have BG color and BG stripe color. So we got to talk about these lines for a moment here. So this line has four important things going on. First, we are defining a variable. Our variable has a name, BG underscore color, for background color. If you notice, that variable name is all capitalized. And typically, we make all of our letters capitalized in a variable if it is a constant variable. When we create a variable in JavaScript, we have to declare that variable. And if that variable is never going to change its value once we define it, we initialize it as a constant or const. Because, once we create our background here, we're not going to change it in the scope of our game. So we can declare it as a const. Now that that variable is declared, we will assign it a value with a single equal sign. And the value that we are assigning here for BG color is hashtag 4A3382. And if you notice, its value is inside of quotations. So I'm going to type out some notes here, or just to help us learn. And anything that is inside of quotes is known as a string. All right, it is known as a string data type. That is the data type of this variable. And our string here, our thing inside of quotations, is really special because it starts with a hashtag or a pound. And that makes it a hexadecimal string. And a hexadecimal string is one of many, many, many ways to define color. All right, we're going to look at lots of different ways that we can define color. Now, this uses something known as the hexadecimal number system, which we should learn a little bit about. Now, in order to begin there, let's just work with a number system we do know a lot about, and that is the decimal number system. All right, if I asked you to start counting, I'd say count the first 10 digits. You're probably going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And you would be great because you are a human being. But computers start counting at 0. We would go 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 as our first 10 digits, because these are the unique characters that we have in our decimal number system. And right here, once we hit 9, we run out of new characters. So how do we keep counting? Well, we go all the way back to the beginning, and we already started at 0, so we shift over. And now we'll start with a 1. And then start over. So 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. And we could go on and on and on. And we'll go on and on and on all the way up to, let's just say, 255. Perfect. This hopefully makes sense. Now, hexadecimal number systems are no different. They have a set of characters, but they don't have 10 characters. They have 16 unique characters. And so if we start counting in hexadecimal, we would go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And before, when we had run out of characters, we had to go back to the beginning and shift. 1, 0, 1, 1, 1, 2, 1, 3. But we have not yet run out of characters. We have 16 characters in hexadecimal. The next character we have at our disposal is the letter A, then the letter B, then C, then D, then E, and then F. So here are our 16 characters to work with. So in hexadecimal, the number B corresponds to 11. In hexadecimal, the number E corresponds to 14. So how do we keep counting? We've run out of characters. Well, to get to our next number, we go all the way back to the beginning. We've already used 0, so we'll start with 1. So I'll do 1 and then start counting again. 1, 0, 1, 1. And this would continue on and on and on all the way to, what is 255 in hexadecimal? It is FF. Now, this relationship is going to be really important for us because when we look at a hexadecimal string defining color, that is actually showing 3 different colors all at once. It's showing red, and our red value is defined as a 2-digit hexadecimal number. It's these first 2 digits right here. So our background color is 4A. It's defining a green color, and our green color is the second 2 hexadecimal digits, 3, 3. And then it's defining a blue color, and our blue color is the last 2 hexadecimal digits, in our case 8, 2. Now, if you mix any proportion of red, green, or blue color, you can get any color of light that you want. So we can finely tune the red channel, the green channel, and the blue channel in our hexadecimal strings to get whatever color we want. Now, if we want none of the red, we would just put it to 0, 0, a value of 0. If we wanted all of the green, we would max it out at FF. So color goes in decimal from 0 to 255, or in hexadecimal, 0 to FF. So with that little lesson on hexadecimal values and color strings, let's approach changing this color of our background. So I don't know, let's make our background completely red. So to make it completely red, I'm going to do FF. I want all of the red. And then I'm going to do 0, 0 in the green. Give me no green. And 0, 0 in the blue. Give me no blue. So now those changes have been made. If I come over here and I refresh my page, hey, my background is now red. Okay, well, that looks really sort of bad. I don't like that. Why don't we also change it so we have all the green? So now I have all the red, all the green. So what will red and green make with no blue? Ooh, they make yellow. Okay, that's kind of looking a little bit better. But that yellow is a little too bright for me. So if I want to dim that yellow or make it not as vibrant or bright, I can lower the red and green in equal proportions. So let's lower the red channel from FF down to 8A. And we'll lower the green channel down to 8A. And now when we run this, we get a muted yellow. Still yellow, but a little bit darker. What happens if we turn on all of the channels to their full color? So all the red, all the green, and all the blue. Well, that gives us white. If you mix all of our colors in equal proportions, we will get white. What if we turn them all off? Give me none of the red, none of the green, none of the blue. What's this going to give us? Ooh, it gives us black. Not the vibe I'm going for here. This is kind of would be like a spooky game. No, I don't want Broshi to be spooky. I want it to be cute and fun. So let's actually define our color here. We're going to do DC in the red channel. We're going to do EF in the green channel and CF in the blue channel. So I have the most green, all right? So I think that is going to look good. Let's see what it looks like. Ooh, and that sort of matches like my background of the game here. I kind of like that. That looks really good. Now, we also want to change our stripe color. Our stripe color right now is 4, 4, 4, 4, 4, 4. Equal portions, red, green, and blue, and they're all sort of dim. So that gives me like that gray color here. But I don't want that gray color. Instead, I want something that is a lot more green. So I'm going to keep the green channel my highest, and I'm going to make it, let's see, CF, E6, C0. So those are the colors that I picked. So my red and blue channels are about the same, and they're lower than my green channel, which is the highest. So now if we run that, we get a nice background color here. I can see I sort of have like almost like a shaded switch between these shades of green. I really like how that looks. All right, mission number 1 is complete. I'm very, very happy with this. So let's go to mission number 2. So in my search bar up here, I can just type out mission 2, and it's going to bring me to the next mission that I have here. So if you want to go back up to the mission checklist, you just hit here, and it says we got to draw the player under the column grid. Because right now, I think those 2 little dots might represent the eyes of my little player, but I think we're missing part of it. So if we come over here, we find ourselves in the draw player function. Now, I always like to say, or I always like to figure out where we are in our code. So draw player, this function gets called inside of draw scene. In draw scene, we draw our background, our drop zone, our player, and our HUD. And we're going to call draw scene. You can stay here because I'll jump for us. I'm going to go up to our P5 game loop functions, right? Setup, which gets called once at the beginning of our game, and draw, which gets called every single frame of our game, is going to draw the scene. So that function gets called every frame of the game, which means it's calling draw player every single frame of the game. It looks like we create a few variables here that are going to be used for positioning. And then we call a really important function called no stroke. It means give me an invisible marker so you do not see the shape that I'm about to draw. And then we call fill. Fill is, think of fill like a bucket that you can pour paint into. And we just poured a paint color in called player color, 5FAE63. The green channel, being AE, is going to be the highest. So this is going to be some shade of green. And now we want to draw the player. So we're going to draw the player's body, and we're going to use a circle. And when we draw that circle, it's going to have no outline, and the circle will get filled in with this paint color. So the way we draw a circle is with the circle function. So we type out the name of the function, circle, and then a set of parentheses to call it. But we need 3 pieces of information in this function in order for it to work. We need the X coordinate of the circle center, the Y coordinate of the circle center, and the size of the circle. So I really want to draw the circle exactly where the player is. So if the player is here, I want to draw the circle here. If the player were over here, I want to draw the circle over here. So we have to understand, how do we keep track of where the player is? In order to understand this, we are going to go to our gameplay variables section. So you can stay here. I'll jump for us, but I'm going to jump into my code to where we exit our student edit zone and we define some gameplay variables. If you look, I have a gameplay variable here called player, and the player variable is defined with the word let. That means it is not constant. Its value will change over the scope of our program. Its X position, its Y position are going to change, and so we got to be able to change that. It is not constant. And our player is equal to an object. If you notice here, we have curly brackets. Those curly brackets indicate that we have an object, and objects have properties. Our player object has an X property, a Y property, and a swap lane property. And each of those properties has values. They are currently all set to 0 when we define this player variable. I'm imagining that they're not going to stay 0 forever, because when we come into our reset game to default section, it looks like we are assigning each of those properties new values. Now, that means our player has an X property and a Y property. We are going to use the player's X and Y property to be the center of our circle. So inside of that circle function in mission 2, let's pass in player dot X. So dot means give me access to everything that you have, and look, the list of properties show up right here. We are going to select the X property, and then we'll do player dot Y. We're going to select the Y property, and then we need a size for our circle. Well, in our student edit zone, I believe I briefly saw it, so I'm going to click in my student edit zone. Let's see what we've got to work with. What constants do we have here? Well, we have a player radius. Since we're using a circle, the radius is going to define how big we want that circle to be. So I will use this constant variable as the size of my circle. But in the circle function, it wants a diameter. So the radius and the diameter are related to each other by multiplying the radius by 2 gives you the diameter. So if I start typing player radius, you can see I get a huge list of options appearing here. I can move up and down this list with arrow keys, and when I find the one I want, I can hit tab to autocomplete it. And that autocomplete is such a wonderful, beautiful feature. We're going to use it quite a bit. So I'll autocomplete that radius, and then I'm going to multiply it by 2 to get the full diameter of our circle. And then at the end here, we'll put a semicolon for good JavaScript practices. And so now we are drawing our player. Let's refresh our game and see this circle appear on the screen. Hey, there's our little Broshi. He's so cute. He's way too small though. I can barely make out any of the details on him. So let's go see what mission 3 has us do. Mission 3 tells us we gotta fix the size of Broshi to make him more visible. So let's go down to where mission 3 appears, and this should hopefully be no surprise. The size of our player finds us in our student edit zone. We can safely change that, and it will not break the game for us. So right now, our player's radius is defined as 8. Let's make him bigger. I don't know. Let's do 100. What's this going to look like? Ooh, that's way too big. He's like eating into our game board, and down here he's probably in our bottom HUD. I definitely don't like that. So let's make him I'm going to make him 25. We'll make him like a quarter of that size. So let's set it to 25. Let's see how he looks. Hey, I think that fits perfect here in this space. So now our character, our player, Broshi, is just the right size. We can make out its detail. It fits wonderfully in this space by simply adjusting that variable. So now if we look, what I really would love to begin able to do is sort of move him around our game board, our game world. Right now I can't do it. The keyboard does nothing. I hit the arrow keys, I hit WASD, nothing. So let's head and see what mission 4 has us looking at. So I'm going to go up to our mission checklist, and it says add the logic to correctly swap the player between lanes. Okay, and let's go see what mission 4 is. It says lane swapping. Complete the lane swap logic. Update which column the player moves to. And this finds us inside of the update player function. And if you remember, update player, I'll jump, you can stay here, is going to get called every single frame of our game because it's being called inside of the draw function. Now, if we look, we've got some variables that we probably got to discuss here. We've got snap positions and we've got swap lane. Swap lane is a property of the player. Now, I think I'm going to head to the whiteboard to sort of mark out and show you what our layout, our game layout is going to look like. So I'm going to draw us a little picture here, and we're going to overview what this system is going to look like for us. So in our game world, we have 6 different columns. So here is our game world. All right, and I will draw 6 different columns. So I'll split this here with one line, and then I'll do, so there's 1, 2, 3 columns, 4, 5, and 6. And so let's label the columns up at the top, and I'll label them starting at 0. So 0, 1, 2, 3, 4, and 5. And so those are our columns, okay? Columns. And then we have different positions that our player can sit in. Our player is never going to be over here, all the way at the edge, or over here, all the way at the edge. Instead, the player is going to be able to be here, 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 or here. And we're going to call those our snap positions. Snap positions. And those snap positions are going to relate directly to the player's X value, their player's X property. And that X property, if you recall, is the center of their circle, center of the circle. So the player's circle could be centered here, 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 or here. The player's circle will never be centered like right here in the middle of this column, okay? That'll never happen. Now, I'm going to erase these for 1 second because those center positions will also number. Let's number them. So our center positions, we can number them as 0, all right? 0, 1, 2, 3, and 4. And those values are going to not only help us position the player by its X value, but eventually they're also going to relate to something that we'll call a swap lane. So our swap lane, if we are in position 0 right here, our swap lane is going to represent these two columns. Because as a brick is falling, okay, if I've got some bricks in this column, and a brick in this column, I might want to swap these two columns. So if we are in position 0, we can swap columns 0 and 1. If we were over here in snap position 1, we can swap columns 1 and 2. If we were here, we could swap columns 2 and 3. We could swap columns 3 and 4, and we could swap columns 4 and 5. And so we are going to relate to, let's just say, we'll put our little Broshi character right here. He has a swap lane. And so the swap lane, that is player dot swap lane, that is another property. So in this position, our swap lane is going to represent 2 and 3, and we'll be able to swap any bricks in those columns. All right, so with all of that said, let's go back now and take a look at what this mission is asking us to do. So mission number 4, it says, okay, complete the swap lane logic. Update which column the player moves to. All right, so what are we doing here inside update player? Well, first we have a variable called move cooldown timer. And if it's greater than 0, we subtract 1 from it, and then we just return. So we just get out of this function. So it looks like we can't just move constantly. There's going to be a bit of a cooldown here. So like if my cooldown timer is set to 10, I will subtract 1 from it and then return, which means get out of this function and don't do anything else that's down here. But if my move cooldown timer is not greater than 0, if it's at 0, this block of code will not run. We're asking a question using this if statement, and we will only run our code if the question in here is yes or true. So let's pretend that we're not in a cooldown, so we can execute a move. It looks like we define a variable here called move direction, and it's coming from a function call. So we're calling a function get input direction. I believe that function is right down here. So let's take a look. In get input direction, it looks like we create a variable called dx, and we set it equal to 0. Okay, and then we ask another question. We ask if a certain key is being pressed down, and that key has a value of 65. Every key on your keyboard has a numerical value. 65 is the key A. So we're asking if the A key is pressed, these two vertical bars mean or the left arrow key is being pressed. If the A key is pressed or the left arrow key is pressed, we execute this line of code, which takes this variable dx, which is set to 0, and we make it -1. And then it looks like we're returning dx. Okay, so we're giving dx back. We're sending this variable back to wherever it was called from. Well, we called it right here. So now move direction would equal -1. Then we ask another question. We say, hey, if move direction is not equal to 0, we want to swap our lane. So if I press the left arrow key, that would indicate that I want my little Broshi guy to move left one spot. And if I press the arrow key again, I would want him to move left again. So we need to move his swap lane and update his snap position, right? His snap position, if we look right here, we're going to update his swap lane. We're going to update his swap lane from being swap lane 2 to swap lane 1, and then we're going to use that swap lane to figure out what his snap position is. That's where his X property is going to go. So let's do that. Let's say, hey, we're going to update player.swapLane, and we're going to add to it the value stored in move direction. All right, so move direction, if we press the left key, is going to be -1. We'll add -1, which means we're going to subtract, and our swap lane is going to decrease. So if I were here in swap lane 2 and I subtracted 1, I'd be moved to swap lane 1. And then if I subtracted 1, I'd be moved to swap lane 0. Hey, let's test this out. Let's refresh the page and see if Broshi moves to the left. Whoa, where did he go? I think he moved to the left. Whoa, he's moving extremely fast. It's almost like he's moving way, way, way too quick. And if we look at mission 5 says we got to adjust the movement cooldown timer to observe how our responsiveness changes. If you remember, we said, hey, we're going to run this function only if we're not in a cooldown. And if we're in a cooldown, if we've moved and we got to wait a little bit, we're going to just return and get out of this function. So we are setting our cooldown timer to 0. So here we made a move, and now we're setting the timer to 0. That doesn't seem right. I feel like we need to set it to some value. Well, what do we set it to? Like 5, 100? I have no idea. Well, we can look up here in our student edit zone, and we can look at what variables we have. In fact, we have a variable right here called move cooldown frames. We are going to wait 10 frames after we move before we can move again. And this value is stored in our variable move cooldown frames. So we're going to use that variable here. We're going to set our move cooldown timer equal to the constant move cooldown frames. I just type move and then I can hit tab to autocomplete. And now we will have to wait 10 frames. Each frame we will just subtract 1 from our timer. So it'll go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And once it's hit 0, this question is no longer yes or true. This code will not run. And now we can move again. So let's test this out now. I refresh the page. And now I slowly move. Well, did I slowly move? Yeah, I mean, I slowly moved. I press it once and it moves over one column. I press it once and it moves over one column. But I can't move right yet. And I can move right off the screen, which doesn't seem right. So I think we got two things we got to fix here with our movement system. I can't move right, and I can move right off the screen, which is not good. So let's go to mission number 6. Mission number 6 finds us back in that function we looked at called get input direction. Now it makes sense that left movement is working because we are asking a question. Did we press the A key or the left arrow key? And if we did, we make dx -1. But we're never asking, hey, did we press the right key? And so we got to link up this input connection. We're going to add another input key here. And the way we're going to do it is by asking a question. So we'll say if, and then a set of parentheses. And whatever question we put in here, if the answer to that question is yes, we are going to run a line of code. The line of code that we are going to run here is we're going to take our dx variable, and instead of having it being 0, meaning no key was pressed, or -1, the left key was pressed, we're going to add 1 to dx. We're going to make it +1, meaning we want to move to the right. The right key or the D key was pressed. So the question that we need to ask is, hey, is there a key down? So key is down, which is a nice function which checks to see if a key is being held down. If the D key is being held down, the code for D, the number is 68, or 2 vertical bars for or, key is down, and then there is no code for the right arrow key, so we just type out right arrow. Perfect. So we're asking that question. And if this question is true now, instead of returning -1 for dx, we return +1. And so when we come back up here and we grab that value, move direction is now +1, and our swap lane, we add 1 to it. So if we were here in, swap lane 2, and we add 1, we'd be in 3, and then we would be in 4. So let's check it. I can move to the left, and now I should also be able to move to the right. Hey, perfect. So I can move back and forth between my swap lanes. I can do it with A and D or the arrow keys, but I can still go off the screen. And so we do not want that. We disappear when that happens. So we have to somehow limit or constrain Broshi's movement. And so let's head to mission number 7 and look at how we can constrain the movement. This finds us back in update player. After we move, after we swap our lanes, we want to modify how far the player can move. And so really, the player should not move. Let's go back to our picture. Our player's swap lane property should not be less than 0, right? Because if it was less than 0, we made it -1, it's over here, and then we're off the screen. So 0 is our lower limit. It's the minimum value of swap lane, and it should not go higher than, let's just say 4, all right? Because if it were 5, it would put us on the edge, and we go off the screen as well. So we are going to constrain the player's swap lane property. The way we do this, we type out, we're going to assign a new value to swap lane. So player.swapLane, we're going to target the swap lane property, and we're going to set it equal to the constrain function. The constrain function takes 3 pieces of information. Those 3 pieces of information are the value that you want to constrain. We want to constrain the player's swap lane property. Then you put the minimum value it can take. Well, the minimum value it can take is 0. So we're going to put 0 in, right? That is according to our picture right here, 0. Perfect. And then the maximum value it can take. Our maximum value is going to be 4. So we're going to put 4 in here. And then a semicolon for good JavaScript practice. All right, so let's check it. Now, are we constraining? This basically says, hey, if your swap lane is going to try to go less than 0, if you wanted to make it -1, we're going to push it back to 0. And if you tried to go greater than 4, you wanted to make it 5 or 6, we're going to push it back to 4. And so now I'm bounded. I'm hitting the left key. I can't go anywhere. And I am hitting the right key, and I am bounded. So this works really, really nice. But we're going to make it slightly better. We're going to make it slightly better because right now, this is always assuming. If we say 0 to 4, that is always assuming that we have 1, 2, 3, 4, 5, 6 columns. But what if we wanted to add more columns? We absolutely could add more columns. If I come up here to my student edit zone and I say, hey, I want more columns. Column count is currently set to 6. What if I make it 8? And I refresh my game, now I have 8 columns. Well, now I've hard-coded that I can only go to swap lane 4. I can't move over here. So we are going to quickly change that. We're going to go back to mission 7, and instead of hard-coding a value of 4, we are going to look at the number of snap positions that we have in our program. So if you look here, remember our snap positions are these 1, 2, 3, 4, 5. I have 5 of them. And so I'm going to use snap positions, and that is going to have a length, and I'm just going to subtract 1 from it. And let's just quickly talk about maybe why this is. So if I come all the way up here, snap positions is defined using a square bracket. Square brackets are an array or a container that you can put information in or items in. And so in here, we are going to put in all of the positions that our player's X value can take. So our player's X value could take this position, this position, this position, this position, this position. So I'm just going to say okay, snap 1, snap 2, snap 3, snap 4, and snap 5. Now, every container or every array has a length to it. The length is the number of elements that are inside of it. So in this case, my length is 5. Also, every element inside of that array has a position in the array. This first element is at position 0, then 1, then 2, then 3, and then 4. So our last element comes in at position 4, and that position is our length minus 1. The length of our array, 5 minus 1, gives me 4, the last position in the array. Now, with that said, if we come back down here and we look, we are taking the length of that array, holding all of our snap positions, all of the x values our player can have, and we're subtracting 1 from it. So if I refresh the page, now I can go left, I can go right, and I can go all the way, no matter how many columns I decide that I want to have. But I like the layout that we had. So making that change here in mission 7, let's go back and make sure we change our column count from 8 back to 6, because I really like that layout. And now if we look, my movement system is still working perfectly. Hey, this is really, really good. Our world looks good. Our player looks good. Broshi's super cute and fun to interact with. The only thing I don't like is this game name here. So let's go to mission 8 and let's change the last thing about this game. And that is our HUD or heads up display identity. We want to change the game and title text. Give your version a custom name. All right, so this finds us in our draw HUD function. Let's overview what's happening inside of the draw HUD function. We are calling no stroke. If you remember, that means give me an invisible marker so you do not see the shape or the outline of the shape that I'm about to draw. And then we call fill. We are going to put some paint in a paint bucket that we can use to draw with. And our paint is going to be called HUD color. Now, if you look here, HUD color, this color is not a hexadecimal string. It says RGBA. So that is an RGB alpha string. There's many ways that we can define color. An RGB alpha string uses a red channel, a green channel, and a blue channel, just like a hex string, except our values are not 0, 0 to FF. They are 0 to 255. So in this RGBA string, I have 255 in the red, 255 in the green, and 255 in the blue. I have all the red, all the green, all the blue. This is going to make white. But it's that last number, the 0.55, that is extremely important here. And that is called the alpha channel. And alpha, or transparency, in this case, is a number between 0 and 1. If the number is 1, it means the color is not transparent at all. You won't see behind it at all. If the color is 0, it means it will be fully transparent. You're going to see completely behind it. Our color has a transparency of 0.55, which means we will be able to see slightly behind our HUD. And that's exactly what I want for a heads-up display, because then I use the rect function to draw some rectangles. Rectangles take 4 pieces of information. The x, y coordinate of their top left corner. So I'm saying x coordinate 0, y coordinate 0. That puts me in this top left corner. And then we need the width of the rectangle and the height of the rectangle. The width of our rectangle is the width of my whole canvas. And the height is my constant variable HUD height, which is set to 60. So I draw a rectangle starting in the top left corner, the width of my canvas, and I make it 60 pixels down. That defines the top HUD. Then I do something similar for my bottom HUD down below. So there are those 2 rectangles being drawn. Once we have the HUD defined, it looks like we put a new paint in our paint bucket, our text color. All right, and that text color looks like it is probably a dark green, and there I see it right there. Perfect. We align our text, saying center it in the horizontal direction, center it in the vertical, and then I set some text size. The text size is currently set to 36. Look, I could change this. I could make it, let's make it 60, and it will make it much bigger. Game name here. Perfect. Now, if you look, we are saying, hey, let's create some text that says game name here. We don't really want it to say game name here. Let's change the text to Broshi. And if you notice, this is a string inside of quotations. So now that we pass that string to the text function, Broshi appears here. I don't like the size of 60. Let's put the size back to 36. I think that was a nice size. And we'll refresh. Perfect. Now, if you look, there's some other things inside of the text function. It takes a horizontal position and a vertical position. Our horizontal position for this string is the width of our canvas divided by 2. That means smack dab in the middle horizontally. And our vertical position is the HUD height divided by 2. So here's our HUD height, and we split it. We are right here. And we're aligning those in the horizontal direction, center, and the vertical direction, center. So we're saying, hey, take the center of our string horizontally, which is right between the O and the S, and place it at width over 2. If I change this from center to left alignment, now we're going to put the left end of the string at our width over 2. You're going to see that shift. And you can see the B now appears right there. If I said, hey, let's take the, let's do this. Let's show this. Let's see. We'll do the top of our string, and we'll align it at HUD height over 2. It shifts it down. So our alignment tells us how we position. I'm going to do Control Z to bring those back to center, because I want to center them at the center of my canvas and the center of my HUD. And with that, I think our first lesson is complete. Let's take a look at what Broshi looks like. Our world looks good. Our player is interacting here. I can really get a feel for what this game is going to begin to look and play like. And that makes me really happy with the progress that we have done so far here in this video. So we've accomplished setting up our world and setting up our player. We're only going to continue to build the game out from here. It's only going to get better and better. And I can't wait to continue that with you in our next video.